Jai Hind everyone. Today in this particular lecture we are going to start with Introduction to Computer Network and OSI model. So before starting OSI model, first we will be discussing about what the computer networks is and what exactly we require, why exactly we require OSI model, right? So let me start with an introduction to computer networks. We can see easily an interconnected collection of autonomous computers which is able to exchange information. That means why the computer network is required? We see to exchange the information we require computer networks, right? So what is the requirement? Basically what we can say, suppose there is a sender S, he is sending some data to the receiver R, right? One is sender, another one is receiver, right? Now he wants to transmit some data, say a particular message, fine. So one is sender, second is receiver. What it is transmitting? It is transmitting a message. Now I say, suppose the sender, in which language he is sending a message, that language is not understandable to the receiver. In that case, what will happen? That means some of the translator, some of the medium that is required, right? For example, suppose right now I'm speaking in English, but the someone else who is listening to me, he doesn't know about this particular language, then he will be listening me. That means my voice he can hear, but he'll not be able to understand what I'm trying to speak, right? That's why we require some sort of, say protocols, right? So when I'm saying that sender is sending some message, that means there must be a communication channel on which the data can travel, right? On which the transmission, with the help of which the transmission could be possible. So we require some sort of medium, right? Now what this medium is? This medium could be anything. It could be guided, it could be unguided, right? So what is guided and what is unguided? Also we can say it could be wired or wireless, right? So that's how the data is traveling. So in fact also we can say that these are the 5 most important components of the computer network. So one is sender, second is receiver, right? They are sending some message, over a communication medium with the help of some of the protocols, right? So that is the one thing, that we need to establish a communication between sender and receiver, right? So what is the requirement of OSI model then? We take the simple example. Suppose I need to create a building, right? So can we start directly creation of a wall, directly creation of the classrooms, directly creation of the laboratories and so on? No, that is not possible. That is not at all possible. Can you assume a building of say 4 floors or 5 floors or 7 floors or 10 and so on without the stairs, without the staircases, without a lift? How you will travel, how you will move from the step 1, from the floor 1 to the floor 10? There must be a channel, there must be a medium through which you can travel that particular path, right? Okay, so that is what we require, a communication medium. That is, in the similar manner we can say that we require a communication medium, right? So what OSI model is, we require a systematic channel. We require a system to be performed. So, what are the uses of computer network? Say, in the many of the applications nowadays we are using on a daily basis. It could be your business applications, your maybe for the business applications we are having a resource sharing, for the printer sharing, some of the communication medium we require. In fact, in the home applications, mobile users, social networking websites, and so on. There are a lot many uses of computer networks. Nowadays, on a daily basis, multiple type of applications we are using. So, here we can see a simple phenomena of the applications of the network. Say, one is client machine, second is server machine. In simple words, we can say sender is sending some request to the server and server will send a response to the client. In the network terminology, we simply say one is client and one is server. Both of them, both of the participants, that means the client and the server, that could reside on a single machine, that could be on the different machines, right, that could be available on the different machines, right. So, distance doesn't matter in this case. Distance doesn't matter in this case. It could be on the same or the different machines. So, what the process is, client is sending a request to the server machine, fine, and server is sending a reply, or also we can say server is sending a response to the client machine, right. And obviously, we require some sort of network. That means, over a network, it is sending a response, and in the same manner, client is sending a request. So, we require a network over there. So, this is just the client server model, which involves the request and the replies, right. This is another example where multiple users are using the multiple different types of applications, right. You can see, okay, this sender is sending a request to this. Here, this is a sender and a receiver. Similarly, on the same time, this could be a receiver for the other machine, right. It is a sender, and it is a receiver over here. And similarly, it is a sender and this is a receiver over here. Multiple users, that means multiple users may simultaneously be using the multiple application, they may be sharing the resources. So, we require a communication channel to communicate with each other, right. So, this is a diagram which shows a peer-to-peer system where are no fixed clients and servers are there, right. So, we come towards the design issues for the layers. Now, first I will discuss what the layers are. When we talk about OSI model, our OSI model is divided or is built up with the 7 layers. It is built up with the 7 layers. So, what are these layers? Okay. Number 1, physical layer. Then we have data link layer, then network layer, next transport layer, then we have session layer, presentation layer, and the final one, that is a application layer. Now, what does it mean by all these layers? Our OSI model is prepared with the combination of all these things, all these layers. That means the functions are divided layer by layer. The system is divided into the form of layers. That means each and every layer is having a special function to be performed, and we can say, or the task to be performed, right? From the very first step, that means when a sender is trying to send some data to the receiver, how it will interact, how the communication will be established, how the connection will be established, how that data will travel. Each and every function is divided with these layers. So, while designing the layers, there are some of the design issues which we need to take care, say addressing, rules for the data transfer, then error control, flow control, multiplexing and routing. What is the source address? What is the destination address? How data will be transferred? Will it be in the form of bits, in the form of frames, in the form of packets and so on, right? What is error control? What kind of error we can get? Suppose I'm sending 110010. That my data is in the form of bits and 110010. This is the bit pattern which I have sent it, right? And now say it at the receiver end, it is receiving 100010. That means this bit is garbled. There is an error on this particular bit, right? So we need to control that error. Okay, then flow control. What is flow control? As the name is indicating, when there is a heavy flow of the traffic, that means a sender is a fast sender and the receiver is a slow receiver. For example, what will happen if suddenly, all of a sudden on your phone, you got multiple messages, multiple notifications and so on from many of the applications? Will you be able to receive that data in a systematic manner? Will you be able to use that data or access that data in a systematic manner? No, that will not be possible, right? So, we need to do a flow control over there. Fine. Then we have multiplexing. Multiplexing, that means, for example, if I take the example of FDM, where we talk about frequency division multiplexing, where we are transmitting the multiple frequencies on a same channel. The data with the multiple frequencies on a same channel, we are trying to do a multiplexing. Similarly, at the receiver end, demultiplexing will take place, right? Multiplexing and demultiplexing, and then routing, which is the optimum route where the data will be traveling. So, here we comes on the reference models. We have OSI reference model and TCP/IP reference model. So, let me start with the OSI reference model. So, we see the OSI reference model is based on proposal developed by the ISO as a first step towards international standardization of the protocol used in the various layers, right? It is called ISO-OSI model. First, I would like to tell the full form of the OSI, that is Open System Interconnection Reference Model, right? It deals with connecting open systems, that means which is open for communication with the other systems, right? That is why it is known as Open System Interconnection Model or OSI model. So, as I told you earlier that there are 7 layers. So, now we will be discussing why we require these layers, what are the functions of these layers. First of all, we will see what the layer is. a layer should be created when different abstraction is needed. What does it mean? That means, suppose at the initial level, I am saying I need to send some data. Fine. How the data will travel? In which form the data will be traveling? Whether there is an error, whether there is a whether the signal which we are receiving or which which are traveling is somewhat attenuated. What will happen in that case? That means whenever we require a different functionality needs to be performed, we need to add on, we need to design a layer, right? So the layer should be created when a different abstraction is required. Each layer should perform a well-defined functions, right? Like we have seen that 7 layers are there. Each and every layer is having a specific task, is having a specific function to be performed. The function of each layer should be chosen with an eye towards defining internationally standardized protocols. Otherwise, what will happen? Your protocol, your model will not be able to cope up with the system. So, when we are designing the layers, that should be chosen towards, like, it should follow some internationally standardized protocol. This is very important point, right? The layer boundaries should be chosen to minimize the information flow across the interface. The number of layers should be large enough that distinct functions need not be thrown together in the same layers, right? In the same layer, out of necessity, and small enough that the architecture does not become unwieldy. So it should be usable. Layers, number of layers should not be large enough so that there is a mixing and it becomes a mess. It should not be like that. And even it should not be very small so that the architecture does not become unwieldy. So that's what we have seen. Like 7 layers we have: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The order of these layers is fixed, and each and every lower layer will be sending some data or services to its upper layer, right? So when we discuss, okay, this is the first layer, but when we design the OSI model, it is the lowest layer. Physical layer, then data link layer up to application layer, right? Let me show you the diagram now. So this is the OSI reference model for which we are talking about, which we will be discussing in this lecture, right? So we can see easily physical layer, data link layer, network layer, transport layer, session, presentation, and application. What these layers are doing? Each and every layer is communicating with each other, right? From where physical layer is getting some data, it is receiving the data from the data link layer. Data link layer is getting some data from the network layer. Network layer receiving from transport layer, and so on. Here we must be having some of the interface through which a user can interact with the system, right? It could be a user or a sending machine, we can say, through which it is sending a request to the server, right? As I told you in the beginning, we require some sort of protocols according to the functionality of the layer. What function the particular layer is going to perform, accordingly we will be having the protocols: application protocol, presentation protocol, session protocol, transport protocol, and so on, right? Okay, now we can see here the data is in the form of bits. Next, at the data link layer, data is available in the form of frames, then in the form of packets, TPDU, SPDU, PPDU, APDU and so on. So what is this? This is the name of unit exchanged. Application protocol data unit, presentation protocol data unit, session protocol data unit and so on. So according to the layer, the units and the protocols we will be using, right. Here we can see the physical layer host router protocol is used. Then at the data link layer host router protocol is used, and at a network layer host router protocol is used, right. So now we will be discussing this OSI model, all the layers of this OSI model one by one. So let me start with physical layer. Physical layer is getting the data from the data link layer. Data is there in the form of bits at this particular moment. Now, when it comes at the physical layer, it will travel in the form of signals, right. So wherever according to the data, wherever we require the either the digital signals are concerned or the analog signals are concerned, so data will be traveling in the form of signals. Fine. And then it is a sender side, this one is a receiver side, right. So it will be received at the physical layer at the receiver side. So simply we can say a physical layer coordinates the functions required to carry a bit stream over a physical medium. Here we require some sort of transmission medium or the physical medium. Fine. It deals with electrical and mechanical specification of the interface and transmission medium, right. So what does it mean by the electrical and the mechanical specification of the interface and the transmission medium? That means how many volts we will be required to transmit one bit, how many volts we may require to transmit 0 bits, right. When we are talking about the binary bits, data will be there in the form of either the 1 or a 0 bit will be there, right. So accordingly, fine. Some more functions of the physical layer include, it deals with transmitting raw bits over a communication channel, but again we are having some of the design issues. What are the design issues? Like we have seen in the earlier slide, the data will be traveling in the form of bits. So to ensure what one side sends a 1 bit, it is received by the other side as 1 bit only, not the 0, right. That means no error should be there. How many volts should be used to represent 1? How many volts are required to present a bit 0, right. So how many nanoseconds a bit lasts? Whether transmission may proceed simultaneously in both the direction or in a single direction. Now what does it mean by the single direction and the multiple direction or the full duplex mode, we can say? When we say the transmission may proceed in one direction only, for example, television, right? It can broadcast the things, but the receiver which is getting the things, it cannot communicate back to the television. If we take the example of normal mobile phones or the telephones, simultaneously both the participating parties can interact with each other, right? So we say the transmission may proceed simultaneously in both the direction or not. it deals with that. How to establish and release the connection. Then how many pins each network connector has and what each pin is used for. That means what is the use of each and every pin, whatever is there in the connectors, which is available in the connectors. So physical layer is also concerned with the following functions. So what are the following issues? That means physical characteristics of interfaces and the medium, then representation of bits, what will be the data rate. When we say data rate, what does it mean by the data rate? The transmission rate. Data rate is the transmission rate, the number of bits sent each second. The transmission rate, the number of bits sent each second. Data rate is also defined in the physical layer, right? Data rate, that is also defined by the physical layer. In other words, we can say a physical layer defines the duration of a bit, which is how long it lasts. Then we see synchronization of bits. That means the clock of both the participating parties. That means the sender and the receiver, that must be synchronized. Then line configuration. What the line configuration is? The physical layer is concerned with the connection of devices to the media. In a point-to-point configuration, two devices are connected through a dedicated link, and in a multi-point configuration, a link is shared among the several devices, right? Then the physical topologies. Topologies could be anything, like either it could be in a mesh topology, either star topology, bus topology, ring topology, and so on. Then the transmission mode. The physical layer also defines the direction of the transmission between two devices. Say, as I told you, it could be simplex, half duplex, or full duplex. Fine. So these are the design issues and the functions of the physical layer, right? Now moving further, we talk about the data link layer. The data link layer is a second layer in the OSI model, right? So what is the main task of a data link layer? The main task of data link layer is to transform a raw transmission facility into a line that appears free of errors to the network layer. Construct data frames, transmit the frames sequentially, and process the acknowledgement frames by the receiver. It will transmit a data or in the form of frames, right? And it will receive an acknowledgement from the receiver, right? So next is it performs error control, then flow control. After that, it also does the channel allocation, which is the biggest challenge in the computer network, right? What is a channel allocation? That means this is the additional problem of the broadcast network. When multiple users are there, who wants to communicate, who wants to transmit some data over a network, then to whom the priority will be given, to whom the permission will be given, who can transmit. If suppose multiple users simultaneously start transmitting the data over a channel, what will happen? What will happen? Obviously, a congestion or collision will occur, right? Multiple frames will collide, right? And all the frames will be garbled in that case. Fine. So we are having a sub-layer of the data link layer, which is known as MAC layer or MAC sub-layer, which is medium access control sub-layer, also known as MAC, right? So this is a diagrammatic representation of the data link layer. We see from the network layer, it is getting the data, right? Or we also can say L3 data. L3 is a layer 3 data. Layer 3 is network layer. So it is getting the data from the network layer. Now, here we talk about the data link layer. The data will be there in a form of frames and it will be transmitted in the form of bits to the physical layer. Now, we will be having a communication medium. Over here, then it will travel, the data will travel from physical layer to the network, data link layer and the network layer. The next is the third layer, that is a network layer, and as I told you, every layer is getting the data from its higher layer and providing the services and the functions to the higher layer. So it is getting the data from the transport layer, if we talk about the sender side, right? And then the data will be there in the form of packets and will be traveled to the transport layer. The network layer is responsible for the delivery of individual packets from the source host to the destination host, right? So these are some of the functions of the network layer, where we can see it is designed for source to destination delivery of packets, possibly across multiple networks or the multiple links. Whereas we have seen the data link layer oversees the delivery of the packet between two systems on the same network. The network layer ensures each packet gets from its point of origin to its final destination. If two systems are connected to the same link, there is usually no need of a network layer, right? In that case, network layer is not required. Fine. So what are the other functions? It controls the operation of the subnet, say addressing, routing, congestion control, interconnection of heterogeneous network. Next, we have the transport layer. As I told you, it is every layer will be receiving the data from the higher layer or the upper layer. So it is getting the data from the session layer. It will be arranged in the form of segments, and those segments will be transmitted over the network to the lower layer and similarly at the receiver end. So we can see the transport layer is responsible for the delivery of a message from one process to another process. So what are the processes? We can see on a single machine, multiple processes can be there. So what transport layer is doing? The responsibility of transport layer is process to process delivery, where we have seen the responsibility of a network layer is host to host delivery. So what are these processes? Let me show you with the diagram. So multiple processes could be there on a single machine. Say at a single time you are using Yahoo, Gmail, Outlook and say some Word file or some Excel file or any kind of things which we are using, and through which you are sending some data, you are trying to communicate with the other person, right? So the basic function is to accept the data from the session layer, split up into the smaller units, right, and then pass to the network layer and ensure that all the pieces arrive correctly at the other end, right? So that's why we say that transport layer is true end-to-end layer. That means process to process layer, right? And multiplex many transport connections on one network connection. So what is multiplexing and demultiplexing? We can see over here the multiple, this is what a multiplexing, different frequencies on a different frequencies. The processes are going on, and now we will be sending on a single channel, and then at the receiver end or a destination we can say demultiplexing will take place. Next we have the session layer. The services provided by the first three layers. First three layers are the physical layer, data link layer and the network layer. That is not sufficient for few of the purposes. That means few of the things are still remaining. So, the session layer is a network dialog controller. What is network dialog controller? It establishes, maintains and synchronizes the interaction among communicating systems. Session layer is responsible for dialog control and the synchronization, right? So, as we have seen, the functions are dialog control, token management and synchronization. The second last layer, that is a presentation layer, is responsible for translation, compression and encryption. When we are sending the data, you can say it could be optional functions. Why optional functions? Because many of the applications are there where we do not require the encryption completely needs to be done, right? Error control, flow control, these are what? These are the mandatory functions, required functions. But if we talk about encryption, it is not like that everywhere we require that. If we take the examples of banking sectors, yes, that is required in those type of applications, but maybe optional in few of the areas. So, the function is, it is concerned with the syntax and the semantics of the information exchanged or transmitted between two systems. The typical service is encoding, manages these abstract data structures and converts different data structures to abstract one and back. And at the last, we have the application layer, and it is responsible for providing the services to the user, right? It contains a variety of protocols which could be incompatible terminals, an abstract network virtual terminal, which is defined that editors and other programs can be written to deal with. A software to map the functions of the network virtual terminal onto the real terminal. For file transfer, that is different naming conventions may be required, right? So, that is the summary of the all 7 layers which we have discussed. That is like physical, data link layer, network layer, transport layer, session, presentation and application. And with the help of this diagram, easily we can see what exactly the function of each and every layer is performing, right? So, I rest my class here only, and these are the references from where I have included the contents in my slides. Thank you.